We will have to recreate the real distance of this object. First of all, we have to take the reference, the 1000 millimeters that we have from the first cube, from the reference cube, and using this fixed distance we will recreate it from the perspective distortion. But before that we will have to install all our things that we did in the first part of this exercise. We have to recreate the perspective construction, the vanishing points, the horizon line, the zero line, and everything we had in the first part. Based on this construction, our eyes perceive this cube. So if we intend to recreate the perspective distortion, which we created when we turned our cube into perspective, we will have to apply fixed perspective rules. As I said, of course, we will not do this for every single object. It will take a lot more time to model the objects in this way. Still, one time we will have to create this so you can understand, as I said, the core of what you are actually doing, not only repeating some exercise. When we continue the edges of our cube, the lines converge into a vanishing point. We will actually use almost all the time the 2-point perspectives, so we will have 2 vanishing points, and they will show us where is the horizon line, the line where our field of view ends. These converging lines that go into vanishing points, the horizon line, and our eyes are always linked. We could have used, for example, another angle for this cube. In this case, these lines, these converging lines into vanishing points, they will turn as well. The only thing that does not turn is our measure tool. Now, if we want to recreate our cube, we'll actually use the same principles that we use to recreate a rectangle. We will continue the converging lines of our cube so we can find out our first vanishing point, and then we will do the same to find out the second vanishing point from the right part. And one more question that can appear: why we are using our front edge, the closer to us edge, as a reference. You can see that I'm using the first point, the 0 point that lies on the zero line, the measure line, and the second point is the end of this segment. We assume that this is the real length of an object in the scale that we are drawing. In this case, yes, we know the distance, but if we don't know the distance, we will draw anything you see in a scale that later might be brought to the scale that we need. Yes, we are using the term the real distance of an object, the real distance depending on the scale that we are drawing right now. We know the distance, it's 1000 millimeters. And once we are using a standard, the millimeters or inches, we consider this segment then to be brought to a standard, the inches or millimeters, whatever. The fact is that the drawing, the vanishing points that we are creating right now, obey the rule of perspective and our viewer's eye. And also the fact that we are interested in that all the lines that form this construction are drawn right, and the model that will result from these lines will be created correctly. By the way, you saw that I've attached these 2 lines and then I used an instrument called trim. In Max we got instruments that work in pair, like trim and extend that you saw. Usually these instruments do separate things, separate opposite things. For example, trim was used to cut the segment. We are passing to our homeworks, that's why I would like to show all these instruments how they work in practice. Next we are getting to our horizon line. Our vanishing points will stop on this horizon line. Everything repeats like in the previous exercise, every single principle. Soon as I said, we will get to our practice, to our homeworks, so we will do all these. The only difference will be that we will do all these quickly using only our eyes. We will not construct all these lines. This will be done only once to show the principles of the perspective that we will use. Next we will get to our second vanishing point. By the way, you must keep in mind that the drawings that we will draw on paper using paper and pencils, applying all this perspective stuff, will obey in somehow a perfect angle of view. Keep in mind that Max is switching before all 3 types of perspectives. Usually we use 2-point and 3-point perspective. Well, 2-point is the most used one. 3ds Max system is changing that automatically. You can see this even on this image that you are looking right now. The segment, the main segment, the front segment. It's not quite straight. In a perspective drawing it should be straight. That's why I'm saying that in a classic perspective view drawing, usually all the objects are drawn right and they kinda perfectly obey the rules. We cannot say that this object is not obeying the rules of perspective. Still, we have some small deviations, and we will have to avoid these deviations also on the images that we will use for our models. The rules in general lines will work with every single image, but keep in mind you'll have to avoid using your eyes and intuition. All these small deviations that actually will appear on every single image when someone is creating a 3D model, any 3D model. By the way, you will also do this in the future. First of all, when we will pass to our homeworks, people search the best point of view for their objects. And while Max is changing all these angles that creates the perspective distortion, we as creators or recreators of this 3D model are usually focused on the best point of view to present our future 3D model. Yes, we are creating on a 3D simulating space, but all our objects, all our 3D objects will be presented on a 2D surface. Next, we'll have to work with our angle of view so we can recreate this object or this segment. That's why we are using one of the converging lines that goes into the vanishing point. The segment of the part of the object that we are trying to recreate is linked to this angle of view, so we will use the same angle or the same line that created this angle, and we will move our pivot point so we can rotate and imitate, as I said, a compass. We are applying the same distance that we have from our object until our horizon, where our field of view ends, and when we rotate we find the second vanishing point of this object or of this segment that we are trying to recreate. Next, we will repeat the same process for the segment itself. The segment, as we said, it was like a reference. In this case, we know the distance. The distance is 1000 millimeters, and what we are actually doing is we take the 1000 millimeter segment and apply it on the zero line, our measure line tool. When we will have random images, this will be done only intuitively. We will use only our eyes to do this. This will be very close, but for us it will be enough. We will be very close, 95% to the real dimensions of that object. Next, we will connect our vanishing point that we obtained, the second vanishing point, with the real length of our object or the front segment. This is actually the link between the real distance and the perspective distortion that we got from this cube. And now you can see, by the way, this deviation that appeared, the intersection of these two lines should be perfectly at the end of this cube, at the end of the edge of this cube. Now, using this intersection point, we will draw a segment. This segment, using the perspective rules, should be a vertical one. And you can actually see that in the upper part of the cube, where the converging line that goes into the vanishing point intersects with this segment, it fits right.